Hey, so funny thing. Um, this is normally a partner day where we do these partner implicit problems. And maybe I should actually, oh, now that I think about it, this would be perfect for our daily Zoom. Oh, I wonder what I should do with the video. Maybe I should do the homework problems. Ooh, wow, we could do that. Sure. Here, you work on this one. Y squared x plus x squared y equals y to the third. Will you take the derivative of that? I'll be right back. I'm going to go get the textbook so that I can do that homework with you. Okay. Did you finish? How'd it go? Are you almost done? Well, if you're watching this, you must be back, mustn't you? Okay. So, um, product rule. Product rule. So the derivative of this times that, 2y dy dx times x plus this times the derivative of that. So all of this is the derivative of that. In fact, I think I'm going to make it a little easier by keeping it color-coded. Now the derivative of this would be 2xy plus the derivative of that times that, x squared dy dx equals, so this is the derivative of that. And then on the other side of the equal sign, we have 3y squared times dy dx. And of course, we're not done until we have dy dx equals. So I'm going to move this and this to the other side. And that will leave me with y squared plus 2xy equals. And on the other side, we have that dy dx. And this is going to have the opposite sign because we moved it over there. This is going to have the opposite sign because we moved it over there. And this still stays 3y squared. So if I'm looking for dy dx, I should end up with y squared plus 2xy over negative 2y minus x squared plus 3y squared. Okay, well, I hope you got that, and if not, I hope you saw how to do it properly, and maybe you want to practice it again tomorrow. All right, last one I want to look at before we dig into the homework problems is this one. 4x squared plus 3y squared minus 2x squared y to the third equals 5, and I want the tangent line at 1, 1. Okay. So we've got an ordered pair. What else do we need for a tangent line? We need slope, so I have to find the slope of this. Slope is the synonym for derivative. Go get me that derivative, evaluate it at that point, and then write the tangent line. I'll be here waiting. Hey, welcome back. So did you have 8x plus 6x, no, plus 6y dy dx minus, product rule, minus 4xy to the third plus 2x squared times 3y squared dy dx equals 0. Derivative of 5 is 0. Yeah, no, really. I didn't want to lose this sign, so I pulled it out, and we'll process that information now. So I'm at 8x plus 6y dy dx minus 4x. There's a 3 there. Is it an exponent? That came from here. Y to the third. That is supposed to be there. Minus 6 x squared y squared dy dx equals 0. Okay, so I have 8x minus 4xy to the third equals 6x squared y squared minus 6y dy dx. Actually, you can kind of stop in here for the purposes of finding the derivative. I just want to solve the equation for this. I myself find it less confusing to actually take that last step or two, x squared y, 6y, to get my dy dx by itself. Now when I plug in 1, 1, I have 8 minus 4 over 6 minus 6. 6 minus 6 is 0. That's going to be an undefined slope. What kind of lines have an undefined slope? Vertical lines. How do I write the equation of a vertical line? X equals the x value that this line passes through. There's my tangent line. Okay, so let's take a look at the homework. The homework seems to be on page 167 through 9, and then it looks like we've got some practice AP questions here at the end. All right, page 167, this is homework 51, and we start with 14 through 16, then we have 24 to 42 multiples of 3, and then we have 49, and on page 169 we're going to do number 4. Okay, seems pretty humane. Let's take a look at 14. X equals cosine y, and the derivatives say find where the slope of the curve is defined. Find where the slope of the curve is defined. Well, what that really means is find when the slope is undefined and say the slope is defined everywhere except here where the slope is undefined. All right, so let's find the slope by taking the derivative. 1 equals derivative of cosine minus sine, leave the inside alone, times the derivative of the inside with respect to x. So negative 1 over sine y equals dy dx. So I want to know when this thing is undefined. Well, this thing is undefined when the denominator is 0. So when is sine of y equal to 0? Well, we know that sine of y equals 0 when y equals 0 or pi. And so, and this is going to keep going, isn't it? So what we could say is this function is defined everywhere, defined for all real numbers except 0 plus or minus pi n. Okay, or you could just say pi n. That would work. Nice. That was pretty straightforward. 15. 15 says x to the third y to the third equals xy. X to the third plus y to the third equals xy. Okay, the derivative and the directions here for this one are the same. Find when this thing is defined. So I get 3x squared plus 3y squared y dx equals product rule y plus x dy dx. Okay, move the dy dx stuff to one side and not to the other. And divide by both sides. So there's my dy dx, and I want to know when dy dx is, where dy dx is defined. Well, the derivative can't be 0, the derivative can't have a 0 in the denominator. So this derivative, the slope of this relation will be defined everywhere except where this is equal to 0. Well, let's take a look at that for a moment. So we want to know when negative 3y squared plus x equals 0, or x equals 3y squared, or y squared equals x over 3. And so then, ew, I don't like where this is going. This is going to a nasty place. So y is equal to plus and minus root x over 3. Now, where's that? Well, we need to plug that back in. We have to replace all the y's with this. Ew, really? Did you do that? Oh, God, I think I didn't read the directions, and I think I just thought that this was take the derivative. But I'll play along. Okay, so we have x to the third plus, instead of y to the third, we've got this thing to the third, which is x over 3 to the 1/2 to the third. Oh, God, there is a plus and minus in front of it. Equals x times x over 3, oh, plus and minus, to the 1/2. Oh, ugh. Can I solve this? I don't know. Oh, okay. Plus minus x over 3 to the 3/2 equals, wait, that's 2 over 2. Huh, so plus and minus x to the 3/2 over 3 also. Oh, and if I subtract that from both sides, I just get x to the third equals 0, or x equals 0. So when x equals 0, I'll put a 0 there and a 0 there, I get y equals 0. Oh, oh, that's very interesting. So at 0, 0, the derivative is undefined. Or instead of derivative, we could say slope is undefined. Okay. Wow. Yeah. That was a lot of algebra. You won't see that on the AP exam or our test. I think this is just a frustrated textbook writer doing that. So bear with them. 16. 16 says, where is the slope defined? And this time we're given x squared plus 4xy plus 4y squared minus 3x equals 6. Hey, this kind of looks like that perfect square trinomial one that we did, but it's not quite. So 2x plus product rule 4x dy dx plus 4y plus 8y dy dx minus 3 equals 0. So I'm going to move this stuff over. 2x plus 4y minus 3 equals negative 4x minus 8y dy dx. And so I divide by that negative 4x minus 8y. In fact, I could even take out a negative 4 and have x plus 2y. Okay, so there's dy dx. Where is the slope defined? Everywhere except where this equals 0. So x plus 2y equals 0, or y equals negative 1/2x. I have to take this and plug it back into all these y's to figure out where that actually is. So let's see what happens. I have x squared plus 4x times negative 1/2 x plus 4 negative 1/2 x squared minus 3x equals 6. All right. So x times x is x squared, and I have x squared minus 2x squared plus I'm going to square this first and have negative 1, no, positive 1/4 x squared times 4 is just going to be x squared. And then this was the original. This is minus 3x equals 6. Okay, so let's tidy things up. All these cancel, and I get x equals negative 2. And what does y equal? Y equals negative 1/2 times negative 2, or positive 1. So I write here that the slope is defined everywhere but at negative 2. This is an AP question. You do have to know how to do this thing. I want to find where the function has a slope that's defined everywhere except where the denominator is equal to 0. Find where the denominator is equal to 0. Plug this back in to find the ordered pair where that occurs. Or at least, the x or y value where that occurs. All right, what are we on to next? 24 to 42 multiples of 3. 24 x sine 2y equals y cosine 2x. They've given me an ordered pair here of pi over 4, pi over 2. And they ask the question, what's the tangent line and what's the normal line here? All right, so I've got the ordered pair. I just need the slope. And I'm just going to make sure that I copied it down properly because I'd hate to waste all the time doing the wrong problem, only to have to do that problem. Right? So that's what I'm going to do there. And let's go. Product rule. 1 times sine 2y plus x times cosine 2y times 2 dy dx. That's a tough one. People are going to drop that 2. People are going to drop that dy dx. Watch out. We did product rule. Equal sign. Product rule again. Dy dx cosine 2x plus y times negative sine 2x times the derivative of the inside. Okay. Move all the dy dx stuff to one side and not to the other. So I'm going to have sine 2y. This moves to the other side, becomes a plus 2y sine 2x. And equals, we moved this over here, so we have cosine 2x minus 2x cosine 2y. And all of that times dy dx. So I need to divide both sides by this, cosine 2x minus 2x cosine 2y. Okay. That's my dy dx. So now I have to plug this in for x's, not here, just here. So 2 times pi over 4 is pi over 2. The sine of pi over 2 is 1. So I have 1 times y is pi over 2 times 2. The 2's cancel. I get pi. If I plug pi over 2 in here, 2 times pi over 2 is pi. Sine of pi is 0. Over. I plug in my x value here. Pi over 4 times 2 is pi over 2. Cosine of pi over 2 is 0. Minus 2 times pi over 4 is pi over 2 times the cosine of 2 times this. 2 times this is pi. Cosine of pi is negative 1. Minus times minus is positive. I have pi over pi over 2, and that leaves me 2. Ta-da! 2 is the slope. Seems like an awful lot of work to get 2. But instead, I'm just going to be really thankful that the textbook writers gave me such a convenient derivative. So then we were asked to write the tangent line, x minus, and I believe that's it, pi over 4. Yep. Pi over 2 equals 2x minus pi over 4. There's the tangent line, that's part A, and minus pi over 2 equals negative 1 half x minus pi over 4. There's my normal line. Okay, it's 27. Same kind of stuff. Here it says use the implicit differentiation to find first and second derivatives. Okay, let's take a look at first and second derivatives for number 27. X squared plus y squared equals 1. Oh, we did this already. We did this in the last video. 2x plus 2y dy dx equals 0. Please remember the derivative of a constant is 0. 2y dy dx equals negative 2x. Oopsie. And so we get that 2y dx equals negative x over y. Okay, there's the first derivative. Second derivative. Actually, I can change colors. So I need the quotient rule there. And that's going to be low d high minus high, minus high d low over low squared. And so that's going to be negative y plus x dy dx all over y squared. Remember, this is our dy dx. We need to plug that in there. And so I will end up with negative y plus x times negative x over y squared. And if we tidy this up, I'll make a common denominator up there. Negative y squared minus x squared over y times 1 over y squared. Well, that's just going to be by the third on the bottom. And I really do want to take that negative out, but I'm not going to. Okay, so there we go. Number 27, first derivative, second derivative. Okay, problem 30. 30 says y squared plus 2y equals 2x plus 1. Okay, 2y dy dx plus 2 dy dx equals the derivative is 2. So dy dx equals 2 divided by 2y plus 2. Hey, can I cancel those? No, but I could take a 2 out of the top and bottom. And so there's first derivative. What are we doing here? We are finding first and second derivative. Okay, so there's the first derivative. I kind of want to say that the first derivative is y plus 1 to the negative 1. So, second derivative is negative 1, y plus 1 to the negative 2 times the derivative of the inside with respect to x. Well, this is the derivative of the inside. So this has to go in there. So what does that leave us? Well, we've got negative y plus 1 to the negative 2 times this y plus 1 to the negative 1. When I'm multiplying and the bases are the same, I add the exponents, and I get y plus 1 to the negative 3, or negative 1 over y plus 1 to the third. Either way. Okay, there's problem 30. How about 33? Oh, just find the first derivative. Okay, y equals cube root of x. Huh. Well, why don't we do this implicitly? I could do this implicitly. I could cube both sides. Oh, 3y squared dy dx equals 1 dy dx equals 1 over 3y squared. What's y? This is y. So 1 over 3 x to the 1/3, and I want that squared. So I get 1 over 3x to the 2/3. Huh. Yeah, I wouldn't do this problem that way, but that was kind of cool. Instead, I would think about this as x to the 1/3, and I would use the power rule. So if I use the power rule, I bring down the 1/3, I subtract 1 from that, and look what I've got, 3 over x to the 2/3. Kind of cool that this implicit path can get me to the same place. But really, no one's going to care. I've never seen you have to do this on the AP exam. But it is cool. I'll grant them that. Do we have to do anything besides find dy dx? Nope. 36 y equals 1 minus 6x to the 2/3. I'm just going to start with the power rule here. Y prime equals 2/3. 1 minus 6x. Don't forget to subtract 1. Don't forget to come back and take the derivative of the inside. Please wake up enough to notice that that's a minus, and so you get minus 6. I'd stop here. You can go further and have negative 4 over cube root of 1 minus 6x. I don't know that you need to, but you could, and on multiple choice, that would be the answer. Okay, that was 36. How about 39? 39 says y equals, what the heck, minus the square root of that. Y. So, yeah, you gotta rewrite this. 1 minus x to the 1/2 to the 1/2. Please don't apply that. Come on. X minus 2 to the 3rd is not x to the 3rd minus 8. So just leave that there. And now take the derivative. dy dx equals derivative of the outside. Leave the inside alone. Don't forget to subtract 1 times the derivative of the inside. The derivative of this is 0. The derivative of this is going to be negative 1/2 x to the minus 1/2. Do not try and simplify this. Please just walk away. Okay? I mean, yeah, because you can turn that into negative 1/4, and you can move these to the bottom and make them square roots if you want, but it's not really going to gain you anything. Life will not be any sweeter for drinking that nectar. Instead, let us move on now. That was 39, and now we have our last problem from this chunk, 42. And we've got sine of x plus 5 to the 5/4. Okay, so y prime, 5/4, sine x plus 5 to the 1/4 times the derivative of the inside. The derivative of sine is cosine, and then the derivative of x plus 5 is 1. That's it. Okay, what else did we have? I think we had something like 16, 49. 49 on the next page. Let's go, 49. Find the 2 points on the curve x squared plus xy plus y squared equals 7. Crosses the x-axis. Crosses the x-axis. You know, a funny thing about that phrase, crosses the x-axis. Y is going to be equal to 0. So we plug in a 0 for y, and we get x squared equals 7, or x equals plus and minus root 7. This crosses the x-axis at these 2 points. So, and yes, you are expected to see that and do that and know that. And oh my God, you should definitely practice these problems some more. All right, so it says crosses the x-axis and show that the tangents to the curve at these points are parallel. So the tangent lines are parallel, which means the slope of the tangent lines at these 2 different points are going to be the same number. Well, let's find out what dy dx is here. We're going to have 2x plus product rule, y plus x dy dx plus 2y dy dx equals 0. So I know that 2x plus y over negative x minus 2y equals dy dx. Sorry, skipped a few steps there. I moved these over to the other side. They became negative. And then I factored out the dy dx, and I divided by these negative things. Okay? And so what do we want to do? We want to put in a 0 for y, and we want to put in a positive root 7 and a negative root 7. Okay, so let's see what happens when we do that. We've got root 7, 0, and negative root 7, 0. We plug in those. We've got 2 root 7 plus 0 over negative root 7 minus 0. So those cancel, these cancel, I have negative 2. Now I'm going to plug in negative root 7, negative 2 root 7 plus 0 over negative times negative is positive minus 0. These cancel, I have negative 2. Well, so the common slope is negative 2 at those places where that relation crosses the x-axis. And so really, this is a great example of writing sentences. So what I want to say is this relation crosses the x-axis at plus and minus root 7 and at both of these places dy dx equals 0. Equals, was it negative 2? Oh, yeah, it's negative 2. Okay, is that all we had to do then? Find the points where the curve crosses the x-axis. Show that the tangents to the curve at these points are parallel. What is the common slope of these tangents? Notice the problem didn't say write the tangent line equations, and yet a lot of students hand in this homework in a traditional year where they do. So don't do that. Read the question, know what you're answering. Okay, last problem is number 4 on page 169. And so here I'm looking at x, y squared minus x to the third y equals 6. Part A says find dy dx. And so, product rule. So 1 times y squared plus 2xy dy dx minus, I really am going to put the brackets there, 3x squared y plus x to the third dy dx equals 0. Derivative of 6 is 0. Distribute that negative throughout. Move some stuff. So actually, I'm going to move these this time, just because. 2xy minus x to the third dy dx equals 3x squared y minus y squared. Divide both sides. And so we get that dy dx is this. Okay? There's part A. Very common on the AP exam to see a problem like that. They'll say something like, show that the derivative of this is this. And so really, they've already given you the answer, but you just need to get your work there. Part B, find the equation for the tangent of each point on the curve where the x-coordinate is 1. Okay, so x equals 1. I put a 1 in there and a 1 in there. I've got y squared minus y equals 6, or y squared minus y minus 6 equals 0. So y minus 3, y plus 2. Do you work? I think it works, because that's a negative 6. That's negative y. Yeah, that works. And so I get the ordered pair 1, 3, and the ordered pair 1, negative 2. And they said write the tangent line equations, didn't they? Write the equation of the tangent line. Each place the x-coordinate is 1. Sadly. Oh, I still have it. Thank goodness. So I'm going to put in 1, 3. So that's going to give me 9 minus 9 over 2 times 3 is 6 minus 1 to the third is 1. And so that's 0 over 5, or 0. So here, n equals 0. And now let's plug in 1, negative 2. 1, negative 6 minus 4 over 2 times negative 2 is negative 4 minus 1. And that looks like negative 10 over negative 5, or a slope of positive 2. I kind of want to go back and check this one. So 1, 3, that's going to be 9, minus 9, yeah, 9 minus 9 is 0. Okay, so what am I writing? Tangent line equations at these places. So one of them, it has a slope of 0. So while I could write this, and they wouldn't mark it wrong, maybe I should think about this as 0 times stuff is 0, and so y equals 3 at x of at 1, 3 tangent line is, and tangent is at 1, negative 2, y minus minus 2 equals 2x minus 1. So, and I'd stop, but just in case there's some of you who didn't stop, 2x minus 2 minus 4y is that tangent line. All right, and I think I saw part C. What did part C say? Find the x-coordinate of each point on the curve where the tangent line is vertical. And now I have erased the derivative. Gots. Tangent line is vertical means I need to deal with that denominator of that derivative. A lesser Kukla would have just said, yeah, you do that on your own. But I'm actually going to go find that derivative again. Okay, so y squared plus 2xy dy dx minus 3x squared y minus x to the third dy dx equals 0. Y squared minus 3xy x squared y divided by x to the third minus 2xy. I believe this is the derivative. All right, so we want to know undefined, which means this has to be equal to 0. So x squared minus 2y equals 0. So when x equals 0, I put a 0 there, I put a 0 there, I get undefined. So x equals 0. What about solving this? So I know that x squared minus 2y equals 0. X squared over 2 equals y. And now I have to take this and plug it in here and plug it in here. All right. Now we're looking for tangent lines, or we're just looking for x coordinate at each point. Okay. There's one. Now let's take this and plug in here for all the y's. X squared over 2 squared minus x to the third, x squared over 2 equals 6. So that's going to be x to the fifth over 2 minus x to the fifth over 2 equal, oh, that's unexpected. I don't know what to make of this. I was not expecting that. I was expecting to be able to solve for an x Oh. Okay, second try. X squared minus x to the third y plus 6x squared equals tangent line vertical. Okay. So y squared plus x times 2y times dy dx minus 3x squared y minus x to the third dy dx equals 0. So we get y squared minus 3x squared y divided by x to the third minus 2xy is dy dx. Then we say this equal to 0. And I say, okay, so x equals 0. But what about this? I get x squared equals 2y, or y equals x squared over 2. And I want to plug that in there. So I have x squared over 2 squared minus x to the third, x squared over 2. Oh, I did make a mistake. Equals 6. So when I squared the top and I didn't square the bottom. So I have x to the 5th over 4 minus x to the 5th over 2 equals 6. So let's make a common denominator. Positive x to the 5th over 4 minus 2x to the 5th over 4 is going to be negative x to the 5th over 4. I multiply both sides by 4. I get negative x to the 5th equals 24. I push that negative to the other side, and then I take the 5th root. So my answer is this relation has vertical slope at x equals 0 and x equals 5th root of negative 24. But yes, not unreasonable AP question. All right, well, I hope these were useful and helpful for you. I really hope you're practicing this stuff. Have a great day, everyone. I'll see you in the next